There are many applications to systems of equations, and one application is in a cost function. Mrs. White is selling baby blankets, and we are trying to determine at what point does she need to, or how many blankets does she need to sell before she is profitable. So they tell us that she earns $30 every time she sells a blanket, but that her costs are $200 fixed cost plus $5 per blanket. So one thing you want to really look for is whenever you see the word each or whenever you see the word per, we know that we're going to be multiplying that value times the number of items. So in this case, I'm trying to first find the revenue function. And when they say function, typically they mean write it in function notation, which means the revenue will be a function of the number of blankets, X. So my revenue, or Mrs. White's revenue, would be that she is earning $30 each blanket. So if I take the number of blankets times 30, that's the amount of money that she is earning. Not her profit, just her revenue. The cost function is how much she is spending. And so her cost function is a little bit different because she has fixed cost of $200 in addition to the $5 each blanket. So the $5 each blanket would look like this, 5 times X. But in addition, she has fixed costs, which are not multiplied by X. It's just the $200 flat fee for, say, buying a sewing machine or something like that. Here are my two functions. Notice here that I have now graphed these two functions for you, and they do in fact intersect at a point. So let's talk about what this graph will tell us. From 0 to 8 blankets, the cost function is above the revenue function. Here's my cost function, here's my revenue, which means it costs more than I'm making up until that point at 8. Past 8, notice the revenue function is above, the revenue function is above the cost function, meaning after 8 blankets, she's making money. Well, I don't know exactly what point this is. It looks like it's 8 comma something, but I can't really tell based on my graph. So if I need to know that value, I can always replace X with 8 to solve. To find that 30 times 8 is 240. So this value is 240. If I'm not sure that that's correct, I can also plug it in for the cost function at 8, and notice that the cost function will also result in a value of 240, which means at 8 blankets, my revenue is 240 and my cost is 240. So on the next screen where they ask us what does that mean, it means when she sells 8 blankets, her cost and revenue are $240. Now, if you know anything about profit, which they don't ask me about, but the profit would be revenue minus cost, which would mean that the profit at 8 blankets is 0. Profit at 8 would be R of X, or R of 8, which is 240, minus C of 8, which is 240. And so the profit would be 0. For the next example, it's not a profit cost question. This one is asking simply for the cost of 2 different items. So in a question like this, I find it helpful to assign a variable. So here it says find the cost per hot dog and the cost per drink. I'm going to let X represent the cost per hot dog and Y represent the cost per drink, so that when I'm writing my equations, I can simply replace cost per hot dog with X. Now I'm going to look back at the question. At the amusement park, 5 hot dogs and 1 drink cost $22. So for that order, I would take 5 times the cost of a hot dog plus 1 times the cost of a drink, and that would cost $22. 2 hot dogs plus 3 drinks would cost a total of 14. That's my system of equations. Now I need to solve the system of equations by graphing, substitution, or elimination. I don't prefer graphing because it's not quite as exact, so I'm going to choose elimination by taking the first equation times -3, because that's going to give me a -3y and a positive 3y that will then eliminate. So I get -15x plus -3y equals -66. I'm going to rewrite this equation so that everything is lined up and add the two equations together to get -13x equals -52. When I divide to solve for x, I get that x is 4. Then I take that 4, I plug it back into either equation. I'm going to choose the first equation. And when I solve, I should find out the cost of y, which is the cost of a drink, which turns out to be 2. Now, in a normal system of equations, I would write my answer as 4, 2, because that's x, y. This one is a story problem, and as such, we need a sentence as an answer. So I would write, hot dogs cost $4 and drinks cost $2. So I'm saying what x stood for and what the result was with the correct label, what y stood for, the result, and the label. This is very similar to the last question. I'm going to use x to represent soft drinks and y to represent boxes of popcorn. And so if Tom spent on 3 soft drinks and 2 boxes of popcorn $15.50, and Carly bought 5 soft drinks and 1 box of popcorn for $16.50, I now have to solve this system to find the cost per soft drink and the cost per box of popcorn. So I'm going to choose to take my second equation times -2, because that again will eliminate the y value, and I'm trying to find the quickest way to find the solution, which gives me 3x plus 2y equals 15.5, which is my original first equation, and -10x plus -2y or minus 2y equals -33. When I add these together, I get -7x equals -17.5. And when I divide, I get x equals 2.5. Which means, of course, that the cost of a soft drink is $2.50. Then I would take that 2.5 and plug it back in for x to solve to find y. That gives me that 2y equals 8. So y must be 4. Again, my solution is 2.5, 4, but that doesn't make any sense because it's a story problem. So I would write my solution as soft drinks cost $2.50 and boxes of popcorn cost $4. My last example is a little different because I'm actually asked to find how many rather than the cost, which is provided, but I'm going to choose to use x to represent how many adult tickets and y how many student tickets. And I'm going to set up my equations in the same way. There are 650 total tickets, so my first equation will be x plus y equals 650, because those are the two values for how many tickets. The other equation will deal with the value of the tickets, which would be 7.5 for every adult ticket and 3.5 for every student ticket, for a total value of 4,375. To solve this one, I'm actually going to use substitution. So I'm going to call my first equation x equals 650 minus y by rearranging it. which means here I will replace x with 650 minus y so that I can then solve to first find the value of y. When I distribute, I get 4,875 minus 7.5y, and then everything else stays the same. These two values combine, so that leaves me with 4,875 minus 4y equals 4,375. Remember, I'm trying to solve to get y by itself, which gives me that y would be 125. Remember that this is not a cost. Y represents the number of student tickets. To find the number of adult tickets, I would then use my first equation and replace y with 125 and find that x must be 525. So my sentence would say that 525 adult tickets were sold and 125 student tickets were sold.